Hello dear friends, and welcome to this video today. In this video, friends, we shall be looking at one of those important physics experiments that you should always expect in your physics practical, guys, and how to answer it. So friends, this is one of those experiments that I don't always like how students always approach it, because for me, I don't really see it be an experiment, because you can actually report the experiment and score all the marks without necessarily carrying out the experiment. So friends, stay tuned and watch this video from start to finish, guys, because at the end of this video you shall discover how you can answer this question and score all the marks, guys, without carrying out the experiment. If I were to answer this question, friends, the question will not take me 2 minutes to answer it. Okay, it won't take me 2 minutes. So friends, watch the video from start to finish, that you're going to see how you can actually take less than that 2 minutes to answer this question and score the same marks like someone who spent the whole day on this question and still did not even score the marks. So friends, do me a favor, friends, because it took me quite a lot of time, guys, to prepare this video for you today. So don't forget to like the video, hit the like button, and subscribe to the channel if you've not subscribed, and share it with your friends so that they can have access to content like this. Thank you very much, guys, and let's dive straight into our video today. Friends, as you can see, the question reads that you are provided with a vibrating tuning fork, a beaker of water, here was supposed to be E, guys, a beaker of water, a pipe, a metal rule. You should determine the speed of sound in air. Good. So friends, there are a number of ways in which we can actually do this, but based on our requirements, based on they've given us a beaker of water, a pipe, a metal rule, and a tuning fork, that is a good hint to know that we have to answer this same question using the resonance tube method. So friends, we'll use the resonance tube method. So friends, and according to the physics practical, the Cameroon A-level physics practical, guys, you need to start by bringing forth a diagram of setup. You start with the diagram, you go to the procedure, you go to the calculations, the conclusions, the inferences, and so on and so forth, guys. So let's say we want to start by bringing forth a diagram of setup. But friends, I want you to note this. Okay, it's very important. Know that the approximate speed of sound in air is about 340 meters per second. Okay, you can look other books out there, they can give you something slightly different from this. It is still the same. This is an experiment. They don't expect you to be accurate. Okay, they don't expect you to be accurate, because the measuring instruments that you've been given are not accurate measuring instruments, and the conditions in which you're carrying out this experiment is not isolated. Okay, yeah, it's not. So all they want to see is a value that makes sense. Okay, that looks almost as the accepted value. So friends, let's see if we can bring some diagram of setup. We have a beaker of water, we have the pipe that is being immersed in it. Then after we must have heard the resonance sound, guys, we need to measure the height, but that's a tuning fork. We have a tuning fork, the vibrating tuning fork, guys. This is how it looks like. I've just sketched something. This is how it looks like, because you have to place it above the pipe. Then we also have to measure the height from the water level up to the ending of the pipe, because that's where we are going to hear our first resonance. Good. So friends, and okay, we are going to label that as the length L. Good. So friends, we should know that the speed of a wave is related to its frequency and wavelength by the equation V equal to F lambda. Good. So friends, and first resonance occurs when the length is the same like what? 1/4 of lambda. Okay, you should know this. It's very important, guys. Now, what actually happens is that, guys, when we start this experiment, right? When we start the experiment, we are going to hit the vibrating tuning fork on a very hard surface. It is going to start vibrating at a known frequency. The frequency is going to be labeled on the tuning fork. So each time you take a tuning fork, guys, what you should first look at it is what the frequency of the tuning fork. It is always labeled on it. So once you've struck it now on a hard surface, now you place it on top. You place it at some small distance above the pipe, while raising the pipe upward gently when the pipe is immersed in the water. Okay, you start raising it up gently with this fork still in position. You're going to hear a very loud sound. Okay, a loud sound. Once you've heard the loud sound, now you stop and measure the length from the water level to the mouth of the pipe. Good. So that's it. So if you're taking it upward and you still don't see a loud sound, now start taking it back downwards. Maybe you've passed the point at which you hear the first resonance. Yes, maybe you've passed it. Good. So friends, and what I always recommend students to do is that, what I always tell them to do is that when this experiment comes, guys, no need to carry it out. Okay, don't carry it out. All you need to do now, because to get this experiment done, you simply need but just one thing. Just one thing. You just need but one thing, this length L. Okay, but since you know the theory that the speed is about 340 meters per second, you can use this speed now to calculate a value for this L such that it will give you 340 meters per second. Okay, you're going to do that on your rough work, guys. You do that on your rough work. So friends, and you should also know the physics so well. Know your physics so well, because it is going to help you so much. Okay, it is going to help you so much. So friends, and like I said, since you know that that first resonance, the point at which you hear the first loud sound, the length of this tube is the same like what? 1/4 of the wavelength, that is lambda over 4, right? So in this case, guys, I want us now to use this speed to solve for the value of L. Let's get the value of L. Okay, let's get the value of L that will give us this speed, and that will be the end of our experiment. That will be the end. Good. So that therefore implies now our lambda in this case is giving us what? 4L, right? Good. So now we are going to substitute our V into this. We are going to substitute our V, which is what? 340 meters per second, and our F, guys. What's our F? Let's just assume that the frequency of this tuning fork, guys, is 1000 hertz. Okay, like I said, each time you take the tuning fork you're using, always try to read the frequency of the tuning fork. Okay, always try to read the frequency, because you get this frequency from the tuning fork itself. Good. So friends, with that we are set to go. So we simply come to our equation and we substitute our V. What's our V, friends? Our V is 340, right? Then our F, which is what? 1000 hertz. Then our lambda, the wavelength for me, is what? 4L, right? That's why we have here 4L. So friends, we are going to solve for this L, and we'll have our L to be, if we divide all through by 4 times 1000, we are going to have L to be 0.085 meters. But friends, keep in mind that they gave you what? A metal rule, right? And a metal ruler will only measure distances in what? In centimeters. Okay, it will only measure them in centimeters. Keep in mind, you measure in centimeters and to 1 decimal place. So if you use this your L as this, they'll mark it wrong. So we have to lift from these meters back to centimeters. We are going to have 8.5 centimeters. Good. So friends, keep in mind that all these calculations shall be done on a rough sheet. Okay, you shall do it on a rough sheet. Don't ever include it in your calculation, otherwise they will assume that you didn't carry out the experiment. They will assume that. So we have everything it takes to solve. Okay, we have everything it takes to finish this experiment and score all the marks. So friends, let's look at our observations. Our observations, guys, we are going to do the procedure later. Okay, we'll do the procedure later. Let's start with our observations. Our observations in this case, guys, simply comparison of what? This length L and the frequency, because you need the frequency. You have to read it from the vibrating tuning fork. Good. So we simply say our observations. We are going to write the length L to be this, and we have our frequency F to be 1000 hertz. Good. So friends, let's now under our calculations, because this is the most important part. Our calculations will tell them that the speed of sound in air, after we must have written this equation, will tell them that it is V equal to the frequency, which is what? 1000 hertz, times the wavelength lambda. From here, lambda is what? 4L, which is 4 times 0.085. okay, which is equal to 340 meters per second. So you're done, friends, you're done. But keep in mind that when you start the experiment, you will not tell them that the speed is about 340 meters per second. You will not tell them. Like I said, all of this shall be done on a rough sheet. Yes. So now under observations, you've written your L to be 8.5 centimeters. and your F to be that. Okay, they don't know how you got this L, only you know it. So now guys, let's start with our procedure. Which will tell them that the setup is as shown above. The vibrating tuning fork was struck and placed at some small points above the pipe. This is it here. While moving the pipe slowly upwards or downward until a loud sound was heard. Great. So friends, keep in mind that you can see I've given this was a different color, right, and here a different color. Always report your experiments in past tense, friends. I have a video where I advise students how to take the physics practical and score all the marks, so make sure you check that out. I'll leave a link to that video in the description for your convenience, guys. Don't enter the hall without watching that video. Don't enter. It's so risky for you entering the hall without watching that video. Good. So friends, then after we have done that, now the length from the water level to the top of the pipe was measured using a meter rule. Perfect, guys. That's all about the procedure. That's all about the procedure. Now friends, you can therefore come under your inferences. Let's see, we'll get the inference here. You can either term that you can either copy all what you have here initially, right? Because the inference is now is the physics of the problem. Okay, the physics of the problem now is your inference. So you have to tell them what part of physics helped you to solve this particular problem. You can answer your inference either in two ways. You can tell them that you use the fact that the speed v is given as f lambda, or that the first resonance occurs when L is the same like what lambda over 4. Okay, but I'll use this one. You can use this or both of them. It keeps you at a good fit. So I'll tell them that the speed of a wave is related to its frequency and wavelength by the equation v equal to f lambda. Good. That's what you can say, friends. So friends, I hope you understood what I said throughout this video. I'll take it again, friends. I said that each time you're being given this experiment to carry it out, no need to carry it out. All you need to get is just the length. Okay, just the length, and you know that the first resonance occurs when the length is the same like lambda over 4, right? Therefore, in pressure, lambda is given as 4L, and you will know this in mind. You know that the speed is about 304 meters per second, and the frequency is given as 1000 hertz. You will read the frequency from the vibrating tuning fork. Don't go to the exam hall and use 1000, friends. Don't do it. Get your vibrating tuning fork and you look at the frequency from it and you use it. You come out to your rough sheet now and equate the speed, this 340, to the frequency times 4L. You can get your length L. Don't put it in meters, because your meter ruler will not give you length in meters. It will not. It measures the length in centimeters and to 1 decimal place. That's what I'm saying, friends, that don't go to the exam hall without watching the video I made on how to score 100 by 100 in the physics practicals. Okay, don't go to the hall without watching that video. The link will be in the description below. Good. So after having this learned now, you are not going to start now with your procedure as if you carry out the experiment, as if you did. This is the diagram that you're going to use. This is it. But when drawing the water level, guys, water has a minuscule. Okay, water has a minuscule, so you always insert the minuscules here. So I couldn't do it. Yes, you insert the minuscules. So friends, after you must have had this your length, you simply come under your procedure. You bring forth all the procedure as if you carried out. Then your observations, where your L is equal to 8.5 centimeters and your F is equal to that. Calculation, the speed of sound in FV is given as all of this. From this your equation, you go there, put everything, and you have your value. Good. Then your inference, you can either say your V is F lambda, or you can say that the first resonance occurs when the length is the same like what lambda over 4, from which lambda is equal to 4L. Good. So friends, I think that's all about the experiment, and watch out, friends, for the next video on the next station we shall see. So friends, like I said, it took me quite a lot of time to prepare all these things for you, friends, and don't forget to like the video. Click on the like button, friends. It goes a long way to motivate me to keep producing more great content for you. Thank you, friends, and share